kinds of functions. First, into function. A function f from the set x to y is called into function if it has a proper subset of a y. That means if there is at least one element in capital Y which is not the image of any element of x. Range पे proper subset of y हेले ताको हमें कहवा into function. Example let x equal to 1 2 3, y equal to 4 5 6. Let f 1 4 2 4 3 5 is a function from set x to y. Let f is called into function because range f equal to 4 5, that is proper subset of y. Next, onto function or subjective function. Number 2 है onto function or subjective function. Onto function or subjective function. The function f from the set x to y is called onto function or onto or subjective function. If range f equal to y. If range f equal to y, we write this function as f x to y onto Example, let x is equal to 1 2 3, y is equal to 4 5. Let f 1 4 2 4 3 5 is a function from x to y. Then f is called onto function because range f equal to 4 5, that equal to assumption a y section that equal to y. Next step 1 1 by injective function. 1 1 or 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 injective function. A function definition a function f from say x to y is called one or injective function if distinct elements in capital X has distinct images in capital Y, that is if x1 y1 belongs to F and x2 y2 belongs to F and x1 not equal to x2 implies y1 not equal to y2. y1 not equal to y2. We write this function as f x2 y1 1. We write this function this type. Example let a example let a x is equal to 1 2 3 y is equal to 4 5 6 7. Let f is equal to 1 4 2 5 3 6 is a function from x to y then f is called 1 1 or injective function because distinct elements of capital X are distinct images in capital Y. Next, 1 1 on 2 function. This is an example of also 1 1 in 2 function because the range f is equal to 4 5 6. That proper subset of the set called Y. Next example of next we discuss 1 1 on 2 function. 1 1 on 2 function or bijective function or bijective function. Definition: a function f from the set x to y is called 1 1 on 2 function or bijective function if it is 1 1 and on 2 function 1 1 function and on 2 function. That means if a function is 1 1 or injective also on 2 or or surjective, then we call it as a bijective function. We write this as f x2 y 1 on 2 1 on 2. Example, let x is equal to 1 2 3, y is equal to 4 5 6. Let f is equal to 1 4 2 5 3 6 is a function from x to y, then it is called 1 on 2 function or bijective function. 1 on 2 function or bijective function. We write this as f x2 y 1 on 2. Sorry, it is called 1 on 2 function or bijective function because distinct elements of x are distinct images in a y and a range a is equal to 4 5 6 that is equal to y. Diagrammatically we represent it that is f x y 1 2 3 4 5 6 1 4 2 5 3 6. Okay. Next, inverse of a function. Inverse of a function. A function has inverse if it is bijective. Inverse of a function. Inverse of a function. Definition. A bijective function. Bijective means 1 and 1 2. A bijective function f x2 y. A bijective function f x2 y has an inverse function f to the power -1 or f inverse y to x. That means if in a function f x is a domain y is a codomain. Whereas in the function f inverse, y is the domain, x is the codomain. The as an inverse function f inverse y to x given by f inverse equal to yx such that xy belongs to f, or pair yx such that xy belongs to f. That means if f is a function and that element in the order of xy, then in the function f inverse we write it as in the order of yx. A function f is said to be invertible if f inverse exists. If f inverse exists. If f inverse exists. For example, let x is equal to 1 to 3, y is equal to 4, 5, 6. Let f is equal to 1, 4, 2, 5, 3, 6 is a bijective function. Then f inverse is equal to 4, 1, 5, 2, 6, 3. 4, 1, 5, 2, 6, 3. Next example, let f up to r is a function defined by f of x equal to 3x plus 5, so that f is bijective. Find the f inverse 1 and f inverse 0. Answer. Given f r to r is a function defined by f of x equal to 3x plus 5. Now we show that first of all it is bijective. That means we show that it is 1, 1 and a 1, 2. We inject it or 1, 1 function. First we test that the function f of x is equal to 3x plus 5 is an 1, 1 function or no. let f of x1 is equal to f of x2. That means 3x1 plus 5 is equal to 3x2 plus 5. That implies 3x1 is equal to 3x2. That implies x1 is equal to x2. x1 is equal to x2. So f of x is equal to 3x plus 5 is and 1 or injective function. Injective function. Next, we test that it is subjective or not. Subjective or onto function. Onto function. Subjective or onto function. Let a y is equal to f of x is equal to 3x plus 5. That imply x is equal to y minus 5 divided by 3. So for all y belongs to codomain R, there exists x belongs to domain R. That means all elements of the codomain R are pre-imaged in the set of a domain R. So its range F that equal to codomain set R. So y is equal to f of x is equal to 3x plus 5 is subjective or onto function. First we show it as a one function. Hence y is equal to f of x is equal to 3x plus 5 is 1 and onto function. 1 and onto function. So it is a biject 1 onto function or bijective function. So its inverse exists. We know if a function is bijective, then its inverse exists. So its inverse exists. Y is equal to f of x. That implies x is equal to f inverse y. X is equal to f inverse y. That implies and is implied by f inverse y is equal to x. F inverse y equal to y minus 5 whole divided by 3. Y is equal to 3x plus 5. That implies x is equal to y minus 5 divided by 3. We we write it as f inverse x is equal to x minus 5 divided by 3. So f inverse 1 is equal to 1 minus 5 divided by 3 minus 4 by 5 3. F inverse 0 is equal to 0 minus 5 divided by 3 minus 5 by 3. Okay. Next, we'll discuss even function and a odd function. Even function and a odd function. Even function. Even function. A function f up to r, that means real number to real number, is called a even function. If f of minus x is equal to f of x for all x belongs to R, means domain R. Example, x square x to the power 4 cos x sec x etc. are even function. Suppose f of x is equal to cos x. That means like f of minus x is equal to cos of minus x. That equal to cos x. That equal to f of x. So it is even. Same way we can prove x square x to the power 4 sec x etc. Next, odd function. A function f r to r is called odd function. If f of minus x is equal to minus f of x for all x belongs to r. Example, x cube x to the power 5 sin x tan x etc. Let f of x, suppose f of x is equal to sin x. F of x minus x is equal to sin of minus x minus sin x. Note, there are some functions which are neither even nor odd function. There are some functions which are neither even nor odd function. Even no कि और भी no. Example f of x is equal to suppose sin x plus cos x. F of x is equal to x square plus x cube f of x equal to e to the power x. These are the functions which are neither even nor odd. Number 2 f of x equal to 0 is both even and odd functions. Even and odd both functions. Number 3 if f of x is a real function, then f of x plus f of minus x is always even function, and f of x minus f of minus x is always odd function. Prove let g of x is equal to f of x plus f of minus x. Then g of minus x, f of minus x plus f of minus x, f of minus x plus f of x, that equal to g of x. So g of x is equal to f of x plus f of minus x is even function. Same, let h of x is equal to f of x minus f of minus x. H of minus x minus f of minus x minus, that equal to minus of f of x minus f of minus x minus h of x. So h of x is equal to f of x minus f of minus x is odd function. So we write it so f of x equal to f of x plus f of minus x by 2 plus f of x minus f of x minus x by 2, even plus odd. Hence every function can be expressed as sum of even and an odd function. Example 12 exercise 1b 12 by let f of x is equal to 1 plus x square, then f of x minus x is equal to 1 plus of minus x square, 1 minus x plus x square. So f of x is equal to f of x plus f of minus x by 2 plus f of x minus f of minus x by 2, that equal to 1 plus x square plus 1 minus x square by 2 plus 1 plus x square minus 1 minus x square by 2, that equal to 2 plus 2x square by 2 plus 2x by 2, 1 plus x square plus x, that equal to even plus odd. Okay, thank you.